And then in the front of the car, there is no more gearbox here in front of the engine. The gearbox is now behind, but now we have a battery here, which is in a T shape.
Three years ago, we started development of the first hybrid powertrain for the new era of Bugatti vehicles. The journey started from a blank sheet of paper. The development set ambitious targets, such as the highest level of integration inside the vehicles and highest performance available on the market. We also adopt in this architecture a motorsport cooling concept, having oil directly cooling the cells, this to maximize the performance. Here we have one of the first development prototypes of the battery. The battery design has this unique shape to achieve two main goals. One is to keep the center of gravity of the whole vehicle low. The second one is to enhance the integration inside the monocoque. We used to call this T-shape, but the main peculiarity of this architecture is the absence of a cover. One of the main targets of the project was to keep the weight as low as possible. So from there we started developing the idea of using the complete vehicle as a battery cover. The battery architecture is based on an 800-volt systems. We have more than 1,500 cells, allowing us to have a EV drive range of more than 60 kilometers and a total peak power of around 700 kilowatt. On this front panel, we can see how the battery looks like while installed inside the vehicle. So basically this panel, it's part of the vehicle itself, while the battery is coming from underneath, and the connection for both the cooling channels where the oil flows, the high voltage and other signals is happening blindly, so through internal connection.
And then the independent front electric axle with two electric motors. As I mentioned already, very high speed, very high tech electric motors with two gearboxes in one housing. Here it looks like a differential housing, or basically one housing, but it's actually two independent systems so that each electric motor is connected to its own wheel. So we wanted to have the cooling for the hybrid system and the combustion engine in the front. We wanted to have more luggage space, and we wanted to have an electric front axle in the front. So that's a packaging marvel, and that was really difficult to do. When you develop a car, you can never look at a single component individually without taking the whole context of the car into account. In this case, there's so much architecture and packaging, as we call it in the car industry, that you don't see immediately here, but I'll explain it to you. So the W16 is a very short engine for its size, but quite wide. And the layout used to be in a way that the gearbox was in front of the engine. Now it's behind the engine. And then that gearbox was feeding the power or torque to the front axle, but also to the rear axle. So the prop shaft for the rear axle went through the engine block to the rear differential. So it was a very wicked layout. We don't actually have that connection now. The rear axle is completely separate from the front axle, and the front axle is two electric motors. There's no physical, no mechanical connection between the engine and the front wheels. But in between now we have a battery, and the gearbox moved from the front to the rear. It also enabled a different aerodynamics of the car, because now we have a narrower engine, which is also tilted in the car. It's actually not straight like here, it's at an angle, to enable a very interesting diffuser, which is double the length of a Chiron diffuser. And that's actually very beneficial, because you want downforce from underneath the car, from the body, instead of wings on top of the car, because it comes with less drag penalty. So you get more downforce for less drag. And in this case we have super long Venturi tunnels left and right of the engine, because the engine is now narrower, and with the angle of the engine and with a lot of trickery that we did also with the rear crest structure and the suspension, which is now exposed in the airflow. So the suspension is also shaped like an airfoil, like a wing basically, because it's in the airflow. The air flows left and right next to the engine, so it was very important to keep it narrow. People sometimes forget that total aerodynamic resistance of a car is the CD times the frontal area. So it's very important to reduce the frontal area, especially for a car that goes the speeds that we do. As you know, we are about breaking speed records, and the Tourbillon is faster than the Chiron. By reducing the frontal area, by bringing the passengers closer together, by having a narrower tunnel, by having the gearbox behind the engine, it all works together as one.